Proof of the integral representation per hypergeometric function. So basically this integral over here is equal to the hypergeometric function, yeah, times a beta function. And in this video we are going to prove this integral to be equal to this one. So how do we begin? We can begin by writing this as a binomial expansion, and since then we have term by term to integrate, it will be easier. Okay, let's see how we do that. Integral from 0 to 1 t to the power b minus 1, 1 minus t to the power c minus b minus 1. Now this will just be sum going from n equals to 0 to infinity of binomial of minus a and n, and then minus tg to the power n dt. Now let's interchange the sum and integral. Sum going from n equals to 0 to infinity, integral going from 0 to 1, t to the power b minus 1, 1 minus t to the power c minus b minus 1. Now this will be minus a minus 1, so on up to minus a plus n minus a minus n plus 1, minus a minus n plus 1. Up to that point it will continue, and over here we'll also have by n factorial, and we also have a minus 1 to the power n over here, yeah, and then t to the power n, g to the power n dt. Okay, now what you can notice is, if we multiply this by minus 1 to the power n, minus 1, each of the minus 1 will be distributed to each of the terms. So we basically have product of a plus 1, yeah, up to a plus n minus 1, and this is defined as the rising factorial of a. There's definition as product from a to a plus n minus 1, yeah, and by n factorial also g to the power n will be here, yeah, a minus 1 to the power n merged with this thing. Now sum from, sorry, not sum, not sum, integral from 0 to 1. So we have t to the power n plus b minus 1 by 1 minus t to the power c minus b minus 1 dt. Yeah. So now this can be done as sum going from n equals to 0 to infinity. This is rising factorial of n by n factorial g to the power n. Now this is just gamma n plus b, gamma c minus b by addition of both of them. That will be gamma n plus c. Okay. Now we can notice that this product is in fact gamma of a plus n by gamma of a, yeah. That's why over here also we can introduce by gamma of b by gamma of c, and then also gamma of c by gamma of b. And the good thing about making this manipulation is now we have a very elegant form. Sum from n equals 0 to infinity, a base n g to the power n by n factorial. Now gamma n plus b by gamma b is just b sub n, yeah, and this one is just c sub n. And now here we have like, let's say gamma x gamma y by gamma x plus y, yeah. So this is beta of c minus b comma b. If you take this outside, beta of c minus b comma b, beta of c minus b comma b outside the sum, we have sum going from n equals to 0 to infinity, of rising factorial of a rising factorial of b by rising factorial of c by g to the power n by n factorial. And this is exactly the defined definition of the ordinary hypergeometric function for a, b, c, and g. Yeah. So we can write this as beta c minus b comma b, and this is hypergeometric function of a, b in numerator, c in denominator, and g as the variable. So this was the proof. The proof involved the binomial expansion and beta function only. So this proof was kind of easy, and I hope you understood the proof. And you can also check other videos about hypergeometric functions on my playlist over here. Thanks for watching. Look forward to seeing you in the upcoming videos too.